For question number 8, I'll be talking about the 5 complexes of the electron transport chain, as well as oxidative phosphorylation in the electron transport chain. In complex 1 of the ETC, we receive electrons from NADH plus H plus. This gives, we give this to coenzyme Q to take it away. In complex 1, it pumps 4 H pluses or 4 hydrogens into the intermembrane space from the matrix. In complex 2, this is known as the lazy complex. So in complex 2, it doesn't pump any H pluses into the intermembrane space. It's very greedy. FADH2 is what gives the electrons to complex 2, who then gives them to coenzyme Q. In complex 3, what happens is coenzyme Q gives an electron to complex 3. This then is transferred to cytochrome C, which is a carrier exactly like coenzyme Q. In complex 3, this is just to continue to move it down the gradient. In complex 3, there is again 4 hydrogens, H pluses, pumped into the intermembrane space. This moves on to complex 4. So complex 4 is what we know as the last electron acceptor. So there will be no more electrons moving on to complex 5. Complex 4 is where it stops. Cytochrome C gives electrons to complex 4. Complex 4 then pumps 2 hydrogens into the intermembrane space. Complex 4 will take hydrogen, oxygen, and electrons out and create water into the body. So it takes all those out, combines them, making H2O. Complex 5 is the ATP synthase complex. In this complex, you are pumping H pluses into the intermembrane space in order to create an electrochemical gradient. Lots of H plus is pumped into the intermembrane space, and few are pumped into the matrix. This is very big differential, lots into the intermembrane space and few into the matrix. This is because H plus wants to move down the gradient, and complex 5 ATP synthase will help with this.